Number 4. It says the city wants to plant rows of oak and weeping willow trees in the park. The city has already bought 24 oak trees and 36 weeping willow trees. They want each row to have only oaks or only weeping willows. What's the largest numbers of trees in each row? Now this word problem is also nice because it used a keyword that we've already been introduced to, and that is largest. So we know, I bet, this is greatest common factor, obviously, because it says largest. Duh. So now, we're going to look at the numbers they want us to find the greatest common factors of. And we have 24 and 36. So now, I'm going to write them down. 24, 36. Again, if you can automatically look at this and see, I know what the number is, Ms. Soto, I got it. That's great. But I'm going to start off with 2, again, to help those who don't know their facts that well, and that's perfectly fine. So if you already know it, you can go ahead, work ahead, and just make sure you check your work with mine, okay? So I'm going to do 2. I'm going to divide both of these by 2. I know that 24 divided by 2 is 12. So I'm going to write 12 underneath 24. And then I have done 36 divided by 2 like 3 times already, so I should know the answer by now. So 36 divided by 2 is 18, because I've done it again like 3 times in this past word problem, or in this past paper. So now I have 12 and 18. We can use 2 again, or because I only have 1 ladder rung left over and I don't really want to have y'all add another one, especially if you're on the computer. I'm going to draw a factor table and see if they have another number in common larger than 2. So I'm going to have 12 and 18. So to start off with, because I like to make everyone's job easier, I have 1 and 12. What's another factor that these 2 numbers have in common? I heard someone say it. They said 2 and 6. Or I meant to say what 12, factors of 12, but they knew what I meant. What is another factor for 12? What 2 numbers can I multiply together to give me 12? I heard someone say it this time too. 3 and 4. I think that's it for 12. Yeah, that's it. So now we're going to move on to 18. Again, I like to make everyone's life easier and put 1 and 18 first, because I know anything times 1, it's itself. What else can I multiply together to give me 18? Heard someone just say it then. 2 and 9. And then someone just blurted out before I can even ask the question. But what else can I multiply together to give me 18? And they said 3 and 6. And that is it. Because we can't do 4 to go into 18. We can't do 5. We can't do 7. Can't do 8. Yeah, so we're done. So now I'm going to circle the numbers that they have in common besides number 1. They have 2 and 3. So remember, like I said, I want to choose the largest factor right now, just because I don't have that many ladder rungs, and I don't want y'all to have to add more from home. If we were here, it'd be a different story. But I want to choose the largest number. So between 2 and 3, the largest number is obviously 2. Now I'm kidding, it's 3. So I'm going to write 3 over here. And now I'm going to divide. 12 divided by 3 is 4. Wait, did I have another? Why didn't y'all tell me? Y'all did not tell me. Miss Soto, they have 6 in common. Y'all didn't tell me that. I'm over here looking silly. They also have 6 in common, you guys. So, my bad. You see, teachers make mistakes. Granted, 3 would have worked, but then I would have added another ladder rung, which was what I did not want to do. So 6 is the greatest out of those 3 numbers. 2, 6, and 3. 2, 3, and 6. The largest number is 6. My bad. So now I'm going to divide both of these by 6. 12 divided by 6 is 2. Then 18 divided by 6 is 3. Now, 2 and 3 are prime numbers. So, since they are prime numbers, they can only be multiplied by 1 in itself to get the number. So, I'm done factoring out. So, I'm going to multiply 2 and 6 together to get our greatest common factor. So, 2 times 6 equals 12. Now, remember, I want you to write your answer in a statement. So where it says answer, that's technically where your statement is supposed to go. So on the side, I'm going to write it in blue. So I'm going to look at the question. So the question is going to help me figure out what my statement's going to say. It says, what's the largest number of trees in each row? So I'm going to say the largest number of trees is 12. And there it is. All right, we got 2 more to go. All right. So number 5 says the PTA has 60 slices of cheese, 90 slices of turkey, and 120 slices of tomatoes. And they don't want any leftovers. What is the greatest number of sandwiches they can make if each sandwich has the same filling? First thing is that keyword. This word problem was nice and used greatest. It made it really easy on us. So my keyword is greatest. That lets me know, okay, well, we're looking for the greatest common factor. Now, this word problem is a little different compared to the other ones. This word problem is different because we have 3 numbers instead of 2. 60, 90, 120. And this is still completely doable. We can still find the greatest common factor of 60, 90, and 120. On your test at the end of this week, you will have a question where you have to find the greatest common factor of 3 numbers. So practicing it now. So I'm going to write 60, 90, 120. And make sure you space them out because you don't want it to look like 6090120. Space them out. Now, however, this one's a little bit easy because what do they all end with? 0. So who remembers what I said? Or, well, you can't answer me. But I hope you remember what I said. If all of the numbers end in 0, they can be divided by what? 10. That's right. So I'm going to divide all 3 of these numbers by 10. So 60 divided by 10 is 6. 90 divided by 10 is 9. And 112 divided by 10, 120 divided by 10 is 12. And you probably see the pattern of what's happening when you divide by 12. If you don't see it, I'm going to show you. Or not 12. I don't know why I'm saying 12. Whenever you divide by 10, if you there's a pattern. If you don't see it, I'm going to show you. When you divide by 10, you're getting rid of a place value. So by getting rid of a place value, we're getting rid of the zeros. So that's a little trick if you didn't learn that in 5th grade. So now I have 6, 9, and 12. Now, all 3 of them are not all even numbers. Only 6 and 12 is. So we can't do 2 because we want to use a factor that all 3 of them have in common. So I'm going to do another factor table, but this time I'm going to have 3 facts. So I have 6, 9, and 12. So we want to find the common factor between all 3 of these numbers. Not just 2 of them, but all 3 of them. If you already know what it is, that is awesome. But if you don't know, please pay attention and watch or work it with me. So I know that the easiest thing I can multiply together to give me 6 is 1 and 6. Also, 2 and 3. And those are all the factors of 6. Now I'm going to do 9. 1 and 9. And 3 and 3. And that's it for 9. So now I'm going to do 12. 1 and 12. 2 and 6. 3 and 4. So now I want to go in here and find the factor that they have in common besides number 1. Now, if they only had 1 in common, then I would be done. But I just want to check and make sure that they have another number in common besides the number 1. And they do. We have 3, the number 3 in common. So that means 3 is going to be our factor that we put on the outside. So now, I'm going to divide each of these numbers by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And then 12 divided by 3 is 4. Now, I know y'all see, oh, well, we have 2 and 4. They can be divided by 2. But we have another number in that last ladder rung. So we are actually done here. So we remember, if there's more than 2 numbers, you have to make sure that all of the numbers in that ladder rung have a factor in common. The only numbers that can be multiplied together to get 3 are 1 and 3. So we are done here because the only factor all 3 of these have in common is 1. So we're done factoring. Now we're going to multiply our numbers on the side and figure out what our greatest common factor is. So our GCF is 10 times 3, which is 30. So I'm going to write my statement on this side, just because I write really big. And my statement's going to say the greatest number of sandwiches is 30. And there it is. All right, we have number 6 to do, and then we will be done with our guided practice. You can already tell if you're looking on your own paper or your own screen, you probably see that number 6 is similar to number 5 a little bit.